Here we go with geometry, section 1.5a, angle relationships. Again, now that we've got angles down, we know how to identify them, name them. They're made up with two rays from a common point called the vertex. The vertex always goes in the middle when naming. Now we've got a bunch of different special types of angles. So I want to run through these. We'll do more with them. We'll practice these a lot, but here's our starting point. So adjacent angles are two angles that have a shared vertex and a shared side. Two angles with a shared vertex and side. So if I made a little diagram over here, I'll end up moving it, but so here is two intersecting lines. I'll call this angle 1, 2, 3, and 4. A shared vertex and a shared side. Here's the vertex. Here's the side. So we could say that angle 1 and angle 2 share the vertex and the side. So angle 1 and angle 2 would be adjacent angles. Vertical angles are two non-adjacent angles, so they don't share a side. They're actually quite the opposite. They're formed by intersecting lines. Vertical angles, I always think the V's kind of help me to see what I'm talking about. So vertical angles are formed, straight across from each other. So if I look at angle 2, a non-adjacent angle would have to be the one straight across from it. So angle 4. Angle 2 and angle 4 are vertical angles. Again, the V helps me because it looks like the two V's pointing at each other or the shared vertex. They do share a vertex, no sides. A linear pair are adjacent angles, so we have to refer back to adjacent. Adjacent angles that form 180-degree angle. So we said that angles 1 and 2 were adjacent, right? Angles 1 and 2 share that vertex and then this side right here. Well, angle 1 plus angle 2, this plus this looks like a straight line, 180 degrees. I hope everybody knows that 180 degrees is a straight line. So angles 1 and 2 would be a linear pair. There are a bunch of other linear pairs on this particular diagram as well. Angles 2 and 3 would be a linear pair. So you can have more than one answer. Just like vertical angles, I should have said that 1 and 3 are also vertical angles. Complementary angles are angles that add up to 90 degrees. Notice it doesn't say that they have to be adjacent. They do not have to touch each other at all. They don't have to share a common vertex and a common side. They just have to add up to 90 degrees, also known as a right angle. So it might look like, here's my right angle. It might look like angle 5 and angle 6. Angle 5 is, say, 60 degrees. Angle 6 is 30 degrees. Sometimes I tell you the degrees. Sometimes I just put that right angle mark in there, so you have to believe me that they add up to 90 degrees. Supplementary angles are going to sound a lot like a linear pair. Whoops. Let me scooch that down now that we're a little farther. Supplementary angles are angles that add up to 180 degrees. The only difference between a linear pair and complementary angles is that a linear pair, they have to be adjacent. They have to share a side and a vertex. Supplementary, they could be two separate angles. So it could be like this guy over here is 120 degrees, and this guy over here is 60 degrees. They add up to 180 degrees. They could touch each other, they might not. And I think everybody knows perpendicular. Oh, before I go on, I should say this. A lot of people get confused or can't remember the difference between complementary and supplementary. So I always just remember alphabetical. C comes before S. 90 is smaller than 180. So numerical and alphabetical order. It's a dumb thing, but it helps to remember. Perpendicular. Hopefully you know the symbol for perpendicular. Perpendicular is like an upside down capital T. So I could say like, oh, line S is perpendicular to line T. Perpendicular means that they form four lines that form four right angles. We all know what perpendicular looks like. That's why the upside down capital T, the symbol for it, makes sense because it's a nice right angle, nice 90-degree angle. So let's do some practicing with this. By the way, I guess I could draw a diagram for perpendicular. Maybe I've got a line P and a line Q, and I put a little right angle box in there, and I would say P is perpendicular to Q. If one angle's a right angle, they're all right angles. That's something we'll talk about too. So there's a whole bunch of different types of angles. Kind of a big deal. You're going to need to know these terms. So I might say in a word problem, these two angles are supplementary. So you're automatically going to have to know that's 180 degrees. So this is important to know. I don't necessarily give you a vocabulary test, but I use the terms and expect that you know what they mean. Or identify two adjacent angles. Well, you're going to have to know what you're looking for. They share a side and a vertex. So perfectly said right here, name a pair of adjacent angles. So adjacent angles share a side and a vertex, right? So you just have to know how to name these, really is what it comes down to, and identify. So I'm going to give you the first adjacent angle, or first angle. I'm going to talk about this angle right here. So if I said name an angle that is adjacent to angle BAN, notice A is the vertex. It's got to go in the middle. You could name it NAB if you want. So there's two different angles. We only list one. So if I were looking for an adjacent angle, it's got to share that vertex A and the side. So if I were looking up here, I might say, well, that side right there, that would be an adjacent angle. So I could say angle BAN and angle BAC. Notice the A is in the middle and the B is in both of them because that's the common side they share is ray AB. You might have been looking on the other part of the diagram though, and you might have seen this instead. This shared side and this angle down here. So we could say, have another answer and say, well, angle BAN is also adjacent to angle NAF. That would be a correct answer as well. Or you could name it FAN if you like fan better. So there's a whole bunch of potential answers on this diagram. That's why I gave you a starting one. All right, next up, name a pair of acute vertical angles. So we already know that acute is less than 90 degrees. Vertical are the ones that are formed straight across from each other by two intersecting lines. So I'm going to take angle BAN off for a second. Actually, I'll put this angle back up there. Angle BAC, I want to start off with that one. So angle BAC has a vertical angle. BAC is acute. Its vertical angle is also acute. It's formed by two intersecting lines. So this is one side of that angle. I'm going to extend it. This is one side of this angle. I'm going to extend it. So whatever is straight across from it using those two segments, or using those two lines. So straight across from it, think of a V. Angle BAC has a vertical angle that is also acute, that is angle FAE. So you have to kind of think of extending those rays to the other side, or what would be the mirror image on the other side. There's another pair of possible answers. I could talk about angle FAN. So this angle down here, and say FAN is acute. What is its vertical angle? And hopefully you would be able to see that angle CAD is the vertical angle for that. It is not a coincidence that they have matching degrees. Name a linear pair. This question is a little bit trickier. I'm going to take some stuff off. Oops. I'm going to try to take some stuff off here. We'll keep that one as our starting one again. We get rid of this other stuff. Pretend you never saw that. All right. So a linear pair. Look at your notes up above. A linear pair has to have two things. It has to be adjacent and it has to add up to 180 degrees. So if angle FAN, I'm going to call it that this time, is 55 degrees, it's got to share a side. It's got to make 180 degrees, 180 and adjacent. So I might have to think bigger than just all these little angles put together. If angle FAN is 55 degrees, I know how many degrees I'm going to need. I'm going to go this way. So here is 180 degrees is a straight line, right? Well, I've already got FAN shaded in, so that 180 degrees has to come from this other part over here. That should all add up to 180 if I took the numbers. How would you name that yellow shaded angle? Two choices. Remember, A has to be in the middle because it's the vertex. So probably NAC or CAN. Even though angle CAN is made up of a couple pieces, the whole thing, along with FAN, makes 180 degrees. Question D is a trick question. Name a pair of supplementary angles. Supplementary angles always add up to how many degrees? 180, right? The difference between supplementary and linear pair is supplementary does not have to be adjacent, but it can. So we could actually reuse our answer from letter C, or we could find another pair of angles that add up to 180 degrees. There's a lot going on in this section because there's 6 different things that we talked about. All right, let's see. I think we're good with acute and obtuse. Let's talk about problem 3. Find x and y so that line KO is something to line HM. Hopefully you recognize this is perpendicular, which means a 90-degree angle. So in other words, they're giving you some trick information in here that you may not have seen coming. KO is here, HM is here, and it says we want them to be perpendicular. So I'm going to erase my messy lines and recognize that this has to be a 90-degree angle. Oh, actually, I'll draw those lines back in. Try to be neat. So we need a 90-degree angle. So x and y, it's 2 different problems. So think about what you want to do first. I think maybe y might be easiest. So my y information is here, which is a part of this whole angle right here, right? So I look for my y once I decide. Well, if you're looking around carefully, you might see that perpendicular gave us a big clue as to what to use, because this 3y plus 6 is that whole 90-degree angle. We've got ourselves a quick and painless equation to solve. So if you want to write down minus 6, 3y equals 84. If you divide by 3, I think that's going to be like 28. So y has to be 28. Easy peasy, right? Once you know what to look for and once you read the directions. How many times has a teacher said to you, read the directions? In geometry, it's imperative because they sneak information in that you might not have noticed. All right, my x information is here and here. So if I'm thinking about these, you might already have a clue. I noticed that my highlighted angle with the y information is vertical to my x information. This, or I said earlier, if things are perpendicular, if one is 90, they all have to be 90. So this has to actually be a 90-degree angle. So angle KJI plus angle IJH has to be equal to 90 degrees. Do you see that this plus this has to equal the whole 90-degree angle? Geometric statement, you're welcome. So I could say that 3x plus 6 plus 9x has to be equal to 90 degrees. I'm going to combine like terms. I'm going to subtract 6. If I'm going too fast or you're struggling with solving equations, please let me know. I'd be more than happy to help you out with that. I'm pretty sure when you divide both sides by 12, that is like a 7. So in order for KO to be perpendicular to HM, your X has to be equal to 7 and your Y has to be equal to 28. Please notice how I'm showing geometric statements, I'm showing algebra problems, I'm showing work, I'm circling my answer. I need to see the same work out of you. Don't just jump ahead and put X equals 7 with nothing. I don't know where that came from. Your work tells me the story of what you did and how you figured that out. I need to see that. That is it for section 1.5a. We'll do a lot of talking about these angles. Have a good one. We'll see you next time.